Hello! In this video I'll show you to set up DaVinci Resolve to start working in HDR, where we'll utilize a color managed workflow. So I have created a new project, and if we go into the project settings and take a look at the master settings, you can see that I have set up with a timeline resolution of 1920 by 1080 and a frame rate of 25 FPS. These settings are not directly related to an HDR specific workflow, and something you can set up depending on your project and if you like to monitor in, for example, HD or UHD. Now let's go into the color management. A color managed workflow is nice because it gives you a lot of control and flexibility, both in terms of getting footage from multiple sources into the same color space and transfer function, and also for managing multiple deliverables. When working in HDR, a color managed workflow allows you to send metadata over HDMI. If you're connected to an I/O device from Blackmagic Design that supports HDMI 2.0a or greater. And this enables C9 users to activate HDR mode on their OLED, which those with a CX series OLED can do with internal settings in the TV's menu. More about that in the next video. In DaVinci Resolve, you have two options regarding the color science for a color managed workflow: DaVinci YRGB color managed or ACES. Personally, I don't work in ACES right now, so I'm going to choose the former. If you'd like to know more about an HDR workflow in ACES, please let me know, as this might be something for me to look into in the future. The first setting we have is input color space, which, as it sounds, regards the color space and gamma of your source footage. I should mention that the word gamma here refers to any transfer function, not only gamma curves. Probably most common for high-end filmmaking, this would be a camera log curve, such as AirLog C or RedLog 3D10. It could also be footage recorded in RAW. In that case, Resolve automatically detects the source and debayers it into the timeline color space. So for RAW files, this setting doesn't make a difference, and you can set it to bypass. If you have mixed sources, it is possible to set the input color space for each clip individually. In the next video, called Managing the PQ Signal, I will show you how to do this. Next, we have a timeline color space. Here there are two different approaches you can take. In the first approach, you can choose, for example, the AirLog C option, or perhaps Red Wide Gamut RGB Log 3D10. This is known as working in scene referred or camera referred. Working in scene referred is a good choice, since it retains the maximum amount of information, both in regards to dynamic range and color gamut. Just make sure to use a camera log format with a big color gamut. Another option is to set the timeline color space to work directly in PQ. This is done by choosing Rec 2100 ST2084, meaning the Rec 2020 gamut and the PQ curve. Setting the timeline color space to the same as the output color space is known as working in display referred. I'm going to instead choose AirLog C here and work in scene referred. Next is output color space. This should be set to the PQ curve, which is either the ST2084 or Rec 2100 standard. Now, with the ST2084 setting, you also have the option to choose between different nit levels, where Resolve will impose a hard clip to the signal, to make sure that it doesn't exceed the maximum luminance level of your delivery. The Rec 2100 option has a 1000 nit hard clip built in, so there's no choice there. Another part of the Rec 2100 standard is the Rec 2020 color space. And if we choose Use Separate Color Space and Gamma, we can see that option being selected. Now, I would recommend you to always select Use Separate Color Space and Gamma, and set this manually. The thing is that if I were not to actively choose a color space and select the ST2024 option, the output color space would be the same as the timeline color space. In this case, the area wide gamut, which is not what we want. This can be confirmed by going to the CIE chromaticity scope, which displays the active output gamut. If we instead select Use Separate Color Space and Gamma, and also choose Rec 2020 manually, we can now see that gamut being active in the CIE scope. When it comes to color gamut and grading in HDR, there are basically two options, which both relate to the P3D65 gamut. Depending on where you're delivering to, you'll either deliver directly in the P3D65 color space, or in a Rec 2020 container limited to P3D65. The reason to limit the Rec 2020 gamut and not deliver any colors outside of the P3D65 gamut is because displays today can show the whole Rec 2020 color space, and how much they can show varies between different displays. This means the colorists and content creators would have even less control over how the colors appear at the consumer end, and limiting the color gamut to P3D65 is a way to manage that. If you wish to work in a Rec 2020 container, limiting the gamut is easily done with the setting Limit Output Gamut to, where you simply select P3D65. If you're grading for a P3 delivery, then you want to change the output color space to P3D65 and keep the transfer function at ST2084. However, when working on a C9 or CX series OLED, I would recommend you to instead use a 2020 container limited to P3D65. This is something I also talk about in the next video in regards to the HDMI signaling override feature. So I'm going to instead select Rec 2020 here.